week. Don't worry. No, it's fine. I was just kidding. Yeah, no. The guy from Facebook will get back to me like next week. No. Like he was like, I gave him a lot of questions. I was like, because I talked to him on Saturday, and I was like, you don't have to do this now. Yeah, Facebook. Yeah.
Let me just make sure this is not.
It won't be an hour. It probably won't be an hour. Yeah, don't worry. It'll be pretty concise. Wait, do I have the clicker? It's not rushed, don't worry. Sound? Can you hear me? Talking. Well, I'm still talking, so you can still hear me. Okay, is that clear? Is this like a good volume? Can it? Yeah?
No, you need a bit louder.
Louder? Wait, like louder here or like I speak louder?
No, you can talk the same.
Wait, I'm turning up the volume here. Is that better? Better? I think everyone can hear me, but like, is this better?
It takes like 15 seconds for you to get.
Oh, okay, so I'm just yelling for no reason. Okay, that's great. All right, how about now? We're still doing some tests, I guess.
There's no sound? Nope. There should be.
Vern's a liar. He doesn't know anything. Oh, whoa. That's pretty cool.
That's pretty small too.
Is it? Should I? Wait, click through it. I just want to see like what the text shows up as. Is it readable? I mean, I assume it is, but yeah, that's not bad. People can read that.
Okay.
That's not bad. I'll also just share the link if anyone wants to see the slides later. Like that's not.
Can you hear? Were you plugging in the wrong port?
No, legitimately, my headphones just broke. Just broke.
There.
Okay.
Totally informed.
Casual. It's casual. Yes. How do I play? Can I hit F5? Is that a thing?
Full screen bottom left.
Bottom left.
Yeah.
There we go. Cool. All right.
So, Xavier, sound?
Sound. Talking. Words. Still talking.
Awesome. Yeah, we got it.
Still talking? Okay, good. We're good? All right, cool. Great. Okay.
Get the show rolling, bro.
All right. Okay, hey everyone. I'm Varun, and this is the first Data Science Club meeting, so I assume you all are here for Data Science Club, or you're here because you're in ACM and just working, which is cool too. So a bit about me. I just transferred here. I'm a junior. I'm a CS major, but I have a lot of interest in like math and stats, and I've done some projects relating to like, data science-y kind of things. So it's something I'm really interested in, something I'm interested in as a career, but I found that at the school we don't really have too much in relation to this. Like there's one, I think there's one machine learning class, and that's only for grad students, and there's one data mining class, but that's not even offered this semester. So I was thinking like maybe if we had a club, it would be kind of interesting to find people who have similar interests, and we could meet together and have these talks and maybe work on some projects. So I'll talk about that a bit later. But for my first presentation, I just wanted to do something on like what is data science. So that's cool. So first of all, I found this Venn diagram, and I thought that was like pretty comprehensive just to kind of go over it. So data science, as you can see, is kind of the intersection of this arbitrary thing called substantive expertise, math and statistics knowledge, and hacking skills. So by hacking skills, I'm assuming they mean programming. So there's programming, there's math and statistics knowledge, and there's substantive expertise. So substantive expertise is like knowing basically about the company you work at or the product you're working on or something like that. So for example, if you're in the healthcare field, knowing about healthcare procedures, maybe what patient's registration, patient data is like. So you can see the intersection of all three of these things is data science. So you can see substantive expertise and math and stats usually gets you traditional research where you're writing papers, but there's not that many applications of it. And so programming and math gives you machine learning, which is a pretty big aspect of data science, but it doesn't really provide expertise into the application you're working on. And danger zone is substantive expertise in programming, which is hacking and doing bad things that you shouldn't be doing. So, wait, next. Okay. So a couple of quotes, just I thought that were really interesting. Eric Schmidt, former CEO of Google, said, every 2 days we create as much information as we had up until 2003. And this quote is actually 5 years old, so I'm sure now it's even greater than that. But basically what's happening right now is as we have more computers, as we have more devices, as we have more information, we collect a lot more data. And data in itself doesn't mean anything unless we have the tools and the knowledge to know, like, what we're working with. And another quote I like is, a data scientist can program better than a statistician and knows more statistics than a programmer. So that's kind of like a very broad thing, but that's kind of what data scientists have, is that they have a knowledge in math, stats, and programming, of course. So a couple of, like, a broad overview of some of the aspects that I mentioned earlier. So first is statistics and mathematics. So a couple types of statistics and mathematics are supervised and unsupervised learning, as well which are branches of machine learning, which I'll talk about a bit more later. There's computer science programming, so obviously like algorithms itself, and then cleaning data and piping data, which have to deal in the data warehousing section a bit more. And obviously scientific methods. So you are a scientist, so you have hypotheses, you have procedures, you're drawing conclusions, and you're seeing what you're working with. So the other thing is, like, there's a huge career demand for data scientists right now. I'm sure you might have heard it. It's kind of like a buzzwordy thing, but yeah, looks pretty good. And there's obviously a lot of jobs and a lot more jobs. But so a lot of these are limited for more graduate and PhD level work. But there's a lot of, as data science tools become more accessible, people with even bachelor's degrees are getting more and more common in the field. So a couple of the applications. So I'll just talk about a couple of things that I'm kind of familiar with. So one of them is business intelligence. So you have, within business intelligence, you have things like marketing. So you want to segment your users. So for example, if I have users, if I want to figure out for my younger demographic, how long do they use my app compared to my older demographic. So if you have all of this data, you can make more sense of it. Like, that's something that you might do as a data scientist. Another thing is recommendations. So if you go on Amazon.com and you're looking at an item, if you look down and you see items that might be similar to this, the way it's doing it is it's doing a lot image recognition, item descriptions, all in the background, and that's how you're finding these recommendations, and similar products as well. And the other thing is pricing. So you want to know what are the best prices that we have, and an example of this is when I worked over the summer. One of the things we did this thing called A/B testing, which is where you test A and you test B and you see which one is more effective, and you give different users like different things and see what happens. So one thing we wanted to test is if we drop the price of our product. We had a sign that said $99 and it was slashed out and it said $79, and we want to see if that was more effective than a sign that just said $79. So like our first theory was that, when you see something that's been discounted, you're more likely to buy it. But it turned out that it actually had no effect. And instead it was the price point of $79 that was more effective than the reduction in the price point. So that kind of helped us price our product and increase our sales. So that's an example of where we use like data science kind of in a way in order to figure out, in order to drive our sales. The other thing is demand forecasting. So for example, if another thing that we did, like where I worked, is we knew the amount of sales that we had at peak times. So we had certain months, where, like holiday seasons, where we had peak sales, and then we had the upcoming, I don't know if you guys remember, there was the Amazon Day Sale. It was mostly like useless stuff, but we sold our product on Amazon on the Amazon One Day Sale, and we were able to correctly order the amount of units that we were expecting because we looked at the past amount of holiday sales, and we were able to predict the right amount of things to order for that day. Another thing is fraud detection within risk. So this is more applicable to banks and things like that. So if someone wants to get a loan, or sorry, if someone sends a credit card, like what's the chance, uses a credit card on your site, what's the chance that it's a fraudulent card? So you have a data set of all known fraudulent cards, and you have a data set of like credit card numbers, which are known to be fraudulent. So you can find similarities between the current credit card number provided. Another thing, another completely different vertical is like within the health industry. So I worked at like a wearable company, which is where we work. So we worked on some things called machine learning, which is where computers can be programmed to predict. It can make decisions without being explicitly told to do so. That's kind of like a very broad way of saying it, but that's kind of what machine learning is. So we wanted to know, like we make a posture sensor, so we know whether you're sitting or slouching. But for each user, their idea of like sitting well is different. So we have like a way to assign what sitting straight is, but for each user, sitting straight might be slightly different. So how do our algorithms change based on the amount of times that you set proper sitting to be? And that's one thing that we incorporated machine learning within our wearable in order so that users wouldn't be annoyed constantly by having to set their posture to be straight. And there's so many more. Like this is just like one thing. And I have a link here. You can see like all these applications of data science. I'll post these slides up later. But yeah. Okay, so I'll talk about some of the programming tools that you might use. So the first of which that a data scientist might use. One of them is R. So is anyone here familiar with R? Yeah. So we have a few people here who've worked with R. But R is a programming language mostly for statisticians, but it's very commonly used because statistics is a huge part of data science. So I guess one day we'll be having a talk on how to use R, maybe by David. Yes, by David? Okay, cool. So yeah, so R syntactically, I don't really know how to describe it. It's the way it treats like arrays. It treats everything as like a data frame, right? Yeah, and that's kind of yeah. Oh, we'll talk about more later. But then we also have Python. Who here has used Python before? I see a lot more people. Okay, awesome. Yeah. So Python is really powerful both as a way to kind of set up your framework where all your data is hosted, as well as it has a lot of libraries built into it which allow for many common things you do as a data scientist. So machine learning, statistics, statistical packages, and they're really popular in Python. And I'll probably be giving a talk on how to use some of those. There's SQL. Who's used SQL, SQL? Databases 134. I guess that's a class. Okay, a lot of people. So yeah, so obviously SQL is a syntactical query language, I think. I don't know. But it's used primarily inside of databases, so to pull and extract data very effectively and very easily. And then you also have platforms and cloud computing. So one thing about data, I'm sure you've heard, and that's kind of where Hadoop comes in. So has anyone here heard of Hadoop? If you went to my talk, you would know. But yeah, Hadoop is is a distributed computing system that usually works very effective for cloud computing. So cloud computing is where you have a computer, like not locally with you, but it's hosted somewhere. And the ability of this is that you can have a supercomputer, that you can just program at home, but it's a supercomputer stored somewhere, and it's doing all these operations for you. And the advantages of this is that when you have huge data sets, like terabytes or petabytes of data, like companies, even smaller companies might have terabytes or petabytes of data. You can do really important operations for your data science things without having to worry about doing it locally. And that's kind of where things like Amazon Web Services, that's one, it's like an online platform for cloud computing. And it's really popular. Okay, so what skills? So actually, I sent out like a little survey to some people I know who work as data scientists, and these are kind of the responses I got from them. So it's kind of wordy, and I'll probably read it out loud. I don't know the best way to do this, but I just got this response like 15 minutes ago. So I made this slide like 15 minutes ago. So sorry if it looks pretty jumbled. But so the first thing, you have to be able to deal with unknown or incomplete situations. So find the needle in the haystack using the best method possible, and then find the needle in the haystack not knowing if there's even a needle to find. So that's kind of, or even the haystack is right. So there's a lot of, you can read the slides. I'm not going to read them all. But yeah. So it's about building these like patterns based on things you might not even know exist, and based on whether or not this data you want is even the data you really need. So also click to the next slide. So you have to be able to recognize and challenge assumptions and biases. So using the haystack example, there will be points where you'll be working on a problem and you'll ask yourself, is this even a needle in a haystack? Am I wasting my time? Should I even be looking for needles? And it's amazing how many assumptions we implicitly make and how many preconceptions we have before we even get to solving a problem. Our challenge, even before we get, our challenge is to first recognize these assumptions and biases and then ask ourselves, is this right? So this is another big thing that comes up in data science is I talked a lot about the math and statistics knowledge that people have, but there are also a lot of programming. So I will read this out loud because that's easier for me to do. So the response I got was, it depends on what side of the data science spectrum you want to be closer to, theoretical or practical. So the closer to the theoretical side you want to be, the more you need to focus on like the math and statistics. Programming comprises of all the skills needed to build like machine learning models, store, retrieve data, and the system to host all this. So like, like the thing I was mentioning earlier with the tools of like Python, R, cloud computing. So this is going to be more like the practical side. And what he goes on to say that basically what you need to do is you need to figure out like what part kind of interests you more, and that's where you'd focus on a bit more. So you can do a lot of these machine learning models without actually knowing how they work. But then you don't really know, did I use the best model? Or like, will I have to change my model as I go? So, and then really quickly I want to touch on like club logistics. I want to make this a really fast presentation because I want to spend some time on this. So I was going to kind of make this open-ended where I wanted to ask people like, what do you want to get out of the club? Was kind of my first question. So if you just raise your hand or shout things out.
I'll take a shirt.
Okay, we'll have to make a shirt. Yes.
Club projects?
Club projects? Yeah, that's definitely one thing I've been thinking about doing. So there's this website called Kaggle, which has a lot of data sets and data challenges. And I was thinking like we can maybe work as a group on some of these projects. And that's one thing I had in mind. The other thing I had in mind is there are a lot of free data sets, and they're like, there's data.gov, which is the United States like government's like everything. So all the census data aggregated. And there's some projects we could do on there. So another thing I want, like if people have ideas, like just shout them out and we'll write them down or something. But yeah.
Predicting the lottery number.
Predicting a lottery number. That would actually be interesting. Okay.
Is it more than just CS guys in here? Bruce?
Oh yeah, let's actually ask. So who here is a CS major? Okay. Who here is not a CS major? All right, cool. That's still a decent amount of people that are not CS majors.
Yeah, that counts.
Okay. But yeah, so that was one thing that I did mention is we'd have a couple of these lectures on how to use some of the tools I mentioned earlier. Because I can't really talk too much about the math or statistics, but I do have Dr. Norris, who's my club advisor. She's really good at all of this stuff, so I'm sure she could maybe talk about it, but it might be a bit really in-depth. But one thing I was thinking of focusing on is the programming side, because that's what I'm familiar with. So I could give, and I know David also wants to do things, right? Yeah. Okay. Yeah. But yeah. So I was definitely going to give some like lectures / talks / presentations on how to use some of these tools. So when we do work on these projects together, we'll know what we're doing. But yeah. So anything else? Anyone wanted to? Oh yeah, shirts was there. Yes.
What were your thoughts about talking to alumni?
Oh yeah, alumni. Let me mention that. So I've been reaching out to some of our alumni who are working as data scientists right now, and a couple of them have been giving me really positive responses. So one of them is he went to Sac State. He's now a data science researcher at Facebook, which, if you know Facebook, it's a really big deal to work there, and it's an even bigger deal to be like a data science like researcher there. And he's willing to, he wants to help out like Sac State. So he really wants to help this club as well. So he's willing to do talks or like, answer any questions we might have. And maybe I'll try to get him to come in one day too. So that would be really cool as well. But yeah, and then I reached out to another alumni, and she's the manager of the data engineering engineering team at Airbnb, which is another like really good company to work at, really hard company to get into. So I think it's really impressive that we have really good alumni who are willing to help us out. But yeah. Yes.
Is this club going to be a section of ACM, or is it going to be its own? I'm just wondering.
It just,
the ACM
like, right now, where's Jonathan? Yes. I feel like you can answer this question as well as me. But, so the idea is that right now I just wanted to find, like, get a lot of people who are interested, and it turns out, the intersection of ACM and people in data science is pretty large. So, I mean, and this room works out really well for us, too. So, but, yeah. But, Jonathan?
I would say, as an addition to that, like, I would say we are separate organizations, but
Right.
we will be doing a lot of combined events, to my knowledge. So
Yes.
our role goal is to help out Data Science Club, and Data Science Club will help us out when they can, and it's just, we just support each other.
Yeah. Yes.
Are they going to be meeting weekly, monthly?
Oh, so I was thinking like maybe bi-weekly. So two times a month. But depending on the frequency of that, I could this is the first meeting. Like I've never ran a club or even done a presentation like this before. But I mean, it depends on what people say. If we think we should meet more often. But ideally, the next one, like we want to do something on like using one of the tools, right? So like an example, like one day on how to use R, and maybe cover that like within an hour. So. But yeah, and then the projects would kind of be independent of the meeting time. That's what I had in mind. Maybe like one evening, or like even on a weekend or something. Like that's another thing we were actually discussing with ACM is like having a hackathon. It might not be data science related, but it's kind of a club thing. It will happen. Yeah. Yeah. Does anyone else have any like questions about the slides? I didn't even ask. I kind of went through them really quickly. I realized that it was like 10 minutes, but yeah. Okay, shirts question mark. So I know everyone wants shirts because who doesn't want shirts, right? I need to figure out like how this whole shirt thing, how do you figure out how this whole club thing works actually? But yeah, but I need to see if we can either get money or raise money for shirts. Yeah. Okay, yeah, but I had a couple of cool shirt ideas in mind, but yeah. Shirts, yeah. Shirts are a key part of a club, along with pizza. It goes like shirts, pizza, content. So, yeah, we'll definitely figure that out. But yeah. But yeah, does anyone have? Yeah.
Is there like a mailing list that you know?
I have OrgSync, and I think OrgSync pretty much sucks because I did send like an event invite, and I guess like no one got it. So I guess I will get an email list going, or I also have a Facebook group, but I guess a lot of people don't use Facebook, which kind of surprised me. But yeah, if you don't use Facebook, just I'll get some email going out, and I'll do it through ACM. Might be the best way initially, but
Or we can help you set up a separate mailing list if you'd like.
okay, yeah, maybe I'll do that and just tag everyone from ACM in it.
Have your Facebook contact add us all into the same
Same.
Have our email, maybe send us letters for address.
I'll do that for you, Daryl. Just for you. But yeah, does anyone else have anything else they want? Like, what are you curious about? Like, why did you come here? Kind of. Let's just want to have like a more open-ended discussion. That's all.
I think like the projects we were talking about doing would be fun.
Yeah.
Good experience as well.
Yeah, for sure, definitely.
Yeah.
Okay. Yeah. So like, it seems like projects are something that a lot of people are pretty excited about. But yeah, that's definitely something we'll do. Yeah.
Yeah. The Kaggle tournaments or whatever.
Yeah.
Have like prize money.
Yeah,
How
they
does
do.
that work out?
Okay. Well.
If we actually got first place, I mean,
Okay. Well,
it's a long shot.
I don't know. That's a long way out. I guess we'll discuss. If like I know Walmart has like a $25,000 one right now.
There's some big.
Yeah, there's some
There's
pretty
also
big
free-
prices.
There's free ones.
Yeah, there's free ones. And the really cool thing is the data sets and the instructions they have too. And then they have a lot of like help guides and forums, which I think would be really help getting us started. But yeah, I mean, if we do want to do like an official like entry between like 25, 50 people, I don't know how that would work out. Maybe like $1 each or something. And it all goes back to the club. And then I export club money to an offshore account. T-shirts and pizza, yeah.
Even a keg would have to get like sweatshirts. It's something fancy going.
Yeah, no, we'll get like jackets. Don't worry. Like Steve Jobs. Okay, but yeah, just like shout anything out, whatever comes to your mind.
Should we start a list for all the people? You have like
Yeah, let's do that actually. Yeah, let me get a piece of paper. That
John, ACM needs to get us a paper.
I need official ACM paper. It's club mandated. Nice. Probably need a pen too. That'd be kind of cool. Oh wait, do you mind passing the pen around? Okay. So I guess I'll just start there and snake it that way. I don't know. We can figure this out. A bunch of CS kids. You guys are smart. Name, email, and yeah, name, email, and like if you want to give your phone number, I guess you can. I don't know. Major, favorite food, pizza preference. Yeah. But yeah, I mean, just like feel free to talk, just chill. I mean, anyone else want to like say something? Yeah, I could have. I had a lot more time. I could have done like a Python thing today. It's okay. Yeah, that's true.
I talked to her. I told her
Oh, did you? Oh, okay. Oh, yeah, I don't.
She said she was going to be writing our homework. And I was like,
Oh, okay. Yeah, I was hoping she would. That's all right. I said. There's also.
but they're not done. She said
What?
we won't get back to
Data collection project.
A data collection project? Like,
Why are we gonna use other people's data?
like use our own data against us? No. Oh,
because I got stuck on the tree.
the what?
Because I was trying to tree my index. That's wrong.
Irvine, UC Irvine has a huge repo.
Of what? Of just like themselves?
Like research generated
Yeah.
before.
Oh, really?
Collected all.
Oh, really? Oh, that's.
North sends us there a lot to UC Irvine.
Yeah, it's
Pull
huge.
data sets off there.
Yeah.
Oh, okay. I just use like the Reddit subreddit for data sets. That one's pretty good too. Yeah. Well, yeah, you can.
Are we good, Bruce?